Hello, this is going to be the code walkthrough for Lab 8. I'll make this a quick one because this was a relatively simple lab. But you can see here I have Scopy up and running and I can toggle between the two modes. That's pretty simple. Anyway, let's start with the walkthrough. So to begin with, I have the header file. The header file basically has externs for the handler for the timer that we're using as our um, PWM, and then the oscillator configuration for it, um, which is used to configure the PWM pulses and duty cycle and stuff like that. I have externs for lookup tables for both the sine and the triangle waves, and then I have a variable that allows me to index through those lookup tables, and I'll get into those when I move on to my main file. And then I have another PWM. This flag basically keeps track of which mode I'm operating in, if I'm in sine mode or in triangle mode. And then I have a signal for debouncing, a variable for debouncing my push button for when I toggle. And then finally, I have an init function, an IRQ handler for the actual PWM, and then I have a callback for my GPIO button for toggling between the two modes. To begin with, here's the init function. So with the init function, the first thing I do is I initialize port C pin 13, which is the blue button on the board. I enable the clock and then I basically configure it as you normally would as an interrupt with a pull down resistor. I initialize the button and then I enable interrupts for that button. Um, the next thing we need to do is initialize port B pin 6, which is the alternate function for the PWM for channel 1 of timer 4. That is where the PWM signal is going to come out of, and this can be found in the reference manual for the F103RB board. But basically, I've set it to alternate mode with no push or pull and a high frequency output, and then I just initialize this. Um, the next thing I do is I enable a clock for the timer 4, which is what we're using. Timer 4 channel 1 is going to be our PWM. I basically just set it up over here. So I played around with the prescaler and period values a little to get something that looked nice. I found that a small prescaler with a high period, and then these periods correlate with what I have in my lookup tables. But I found that these were the best. Um, these are the best configurations. I just kind of played around with it until it worked. Uh, and then I'm configuring the PWM mode. So PWM1, it's counting up. Um, the polarity is high. And then I've set the pulse width to be 500 from the period's 1000 and the pulse width is 500, which gives me a duty cycle of 50%. I start off at 50% and then I can go ahead and increment or decrement it as needed. From here, I start the interrupts for the first for timer 4, and then I um, enable the interrupt handler and then give it a priority and start it up. I start PWM mode in sine mode. So initially, when the board boots up, it'll go ahead and output a sine wave, and then I start the PWM from here. Uh, so that's basically like how it gets set up. Once that's done, um, really the only thing that needs to happen is the user needs to toggle the blue button for it to change between triangle and sine wave. Um, and then I have the PWM IRQ handler, which is triggered whenever the PWM, um, whenever timer 4 channel 1 generates an update event. This gets triggered. And really all I'm doing here is I'm checking which PWM mode I'm operating in, and depending on that, I send a value from the sine or triangle lookup tables to the pulse width. So we're just modulating the pulse width by changing that pulse value. Um, and then I configure the channel, the timer for channel 1 with the new values that I passed in, and then I start up the PWM again so that it's ready ready to generate that pulse. Then I increment the LUT index for the next iteration um, of the PWM signal. And then finally, the last thing to do is you need to clear the interrupt flag in the status register. There's only one bit that's going to toggle high, but I write a 0 to that whole register. That's kind of like nuking it, but that's okay. Finally, we have a callback for our GPIO pin. This is a pretty standard IRQ handler for the GPIOs. All I have here is I'm passing in GPIO pin 13 to it, and then I toggle the PWM mode between 1 and 0. And I've defined these guys up here. So sine mode is 1, triangle mode is 0. I'm just toggling it on and off. And then this is basically logic for debouncing. I check to see what time the interrupt was triggered and what time the last interrupt was triggered. I keep track of that. So I subtract the two values, and if it's less than 200 milliseconds between two interrupts, that means we're still debouncing. So that's basically what I've done here. From here, we can go on to our main, which includes the output, the lookup table values, and the externs that we included here. I need to get rid of this line. This is not used anymore. A remnant from old code. Basically, we have the timer handler, the timer handler's configuration values, and then I have a lookup table here that I don't know what happened to Stack Overflow. I found this sine lookup generator. So basically what I did was I put in a 256 value with a max amplitude of 1000, and I just did this, and that's where I generated my sine lookup table. So I basically just copy pasted this lookup table that I found on this website, and I did it that way. There's similarly a lookup table generator for triangle waves. So if I pass in the same parameters here, which I did, it generates a lookup table for a triangle wave, which I am also using down here for a lookup table for my triangle wave here. So you'll notice that the values all match up. So that's basically where I found those. I'm gonna put in references to these. But I'll spare you the details. I'll do that later. I'll put a reference into the code for those websites. And then I have since I only have 255 indices for this, I'm using an 8-bit value to keep track of which of the indices I'm going into, and then I just let this one overflow. So that was basically how I do that. And then I have another variable for keeping track of which mode I'm in. That's being externed in the header here. So that's all done in main. And then basically all I do is I hal init sysclock init from lab 4. This is the system clock configuration that we did a bunch of labs ago. And then I initialize the PWM, and then I just sit in a while loop. That's all I do. And then it just takes care of everything for me. I think that about covers all of the code. This was a pretty short lab. I didn't write a lot of code for it. And most of the stuff Hal was taking care of for me. So I tried doing this without the general purpose timers initially, but I found that to be a lot more cumbersome. Anyway, I think that about covers everything that I needed to cover for this lab. If I missed anything, let me know, and I'll be happy to get back to you, take a look at it. Thanks.